Hello class and welcome to our first lesson on chapter 1 on points, lines, and planes. Those are the three undefined terms of geometry: point, line, and plane. These three terms really make up every geometric shape that we talk about this trimester. So point, line, and plane are three very important terms that we need to understand. The first one that we're going to talk about is a point. A point is simply a location. It does not have any size. So when you look at a map, for example, and it tells you where Minneapolis is, there's a dot there, we call that a point. Or there's a dot at Los Angeles or a dot at Chicago. It's not telling you the location of that community, whatever the case might be. All it is it's a location. It tells you where it is. Now, when we label points, the way we name it is by calling it point A, by writing it out, or if you want to abbreviate it, PTA, that's just fine. Or you could just write one letter and it is A. But the big thing about this one is that it must be a capital letter. Points are labeled with one letter and it's with a capital letter. Or with point B, or it could be point X, or it could be point Z, whatever the case might be. All you gotta do is label it using the name of the letter, and it's always going to be a capital letter. So that's what a point is. A line is a straight figure made up of points. It's a straight figure made up of points. A line has no thickness or width. So when you go from point A to point B, for example, here is point A, here is point B. In geometry, there's no such thing as a curved line. Okay, we might hear that sometimes. There's no such thing as that curved line. There's no such thing as this. We would call this an arc, and we get to that a little bit later. But when we say a line, we assume that it is straight. So it is the shortest distance from point A to point B. So we'll use this example that I have up here on my smartboard. Ways to name a line. We name a line using two letters. We label it CE, so from point C to point E, or really any 2 points that are on the line. We could also label it line ED, from here to there. Remember, a line goes infinitely in both directions, so it never comes to an end this way, it never comes to an end this way, it keeps on going forever and ever and ever. That's what a line is. So we could use these letters in any order as well. We could call it line DE, and that would be the same name for that line. We could call it EC, or we could call it DC, or we could call it CD. We could call it any of those two names as long as we use two letters to name it. And again, it's two capital letters. Or we see this lowercase m. That's also a way that we could label a line. So right here, if we label it using one letter, it has to be lowercase. If we use a capital letter, then we would be talking about a point again. So that lowercase letter, that's what tells us that it is a line instead of a point. And then our third undefined term of geometry is a plane. A plane is a flat surface made up of points. A plane has no depth and extends infinitely in all directions. So it's kind of confusing how it extends infinitely in all directions. It's hard for our brains to concept infinity. It's hard to put it down on a piece of paper. You can't write on a paper an infinite distance. So oftentimes it's labeled using this parallelogram or quadrilateral. But don't get in your head that all planes are this shape. Planes extend infinitely in all directions. But points and lines lie on planes. So we could label a plane F, G, and H, those points lie on plane P. Here's this plane P right here. Or I could have this line right here, and I might call it line B, C. That line also lies on that plane. So we could label a plane in different ways as well. A point is labeled with one capital letter. A line is labeled with two capital letters. A plane is labeled with three capital letters. 3 points that lie on that plane. And those three letters could be in any different order. F, G, H, GHF, FHG, HGF. You could label those three letters in any order as long as those three letters lie on the plane. Another way that we could label it is this plane, this script P, or sometimes I think of it like this capital cursive letter. That's also a way that you could label a plane instead of using three letters. So sometimes our geometry book, some geometry tests and stuff like that, will have this cursive letter up there. That's also another way to label a plane. So those are the three undefined terms of geometry: point, line, and plane. A lot of terms in this first section. Space is another term. It's a boundless three-dimensional set of all points. So it's kind of like the air that we breathe. It's three-dimensional. Okay, it's where we live. That is what space is. Collinear. Co right here means the word same. Like co-captain is two captains that have the same role. Co-pilot are two pilots that do the same job. Collinear means same. So same line. That's what collinear means. It's points that lie on the same line, even if the line is not visible. So these three blue points right here, I can draw a line that goes all through all three of them, so they are collinear. So then non-collinear, the exact opposite, is points that are not on the same line. So if I draw one line, there's no way to draw a line that goes through all 3 points. This line goes through 2 points, but it doesn't go through all 3. This line in the same way goes through 2 points, but it doesn't go through all 3. And remember, lines are not curved. They are straight figures made up of points, so that isn't a line either. Lines have to be straight. So non-collinear is when they're not on the same line. Same thing here with coplanar and non-coplanar. Co means the word same, so they're on the same plane. Figures that are on the same plane. So points and lines oftentimes lie on a plane. Non-coplanar then is not on the same plane. If things are non-coplanar, they do not lie on the same plane. We'll talk about examples when you get to class tomorrow. Parallel lines are coplanar lines that never intersect. I'm guessing you've heard of the term parallel before. Now we're putting a little bit of a geometric definition to it, because parallel lines always lie on the same plane. They are coplanar lines that never intersect. So they never get any closer to each other. They never get any further away from each other. They stay the same distance forever and always. They're noted with these symbols right here. When there's arrows on parallel lines, it means that those lines are parallel. Very similar now with parallel planes. 2 planes that never intersect. So one thing I like to consider this as is the floor that you're standing or sitting on, and the ceiling that is above you. I'm guessing those 2 are parallel planes. They are completely horizontal, so if they were to extend infinitely in all directions, they would never get any closer to each other, they would never get any further away from each other. Those 2 planes are parallel. So parallel planes, 2 planes that never ever intersect. So similar to parallel lines is skew lines, where parallel lines are coplanar lines that never intersect. Skew lines are non-coplanar lines that never intersect. So that's the difference between the 2. On this box on the left side, if I have DC and AB, those are parallel lines. They're on the same plane and they'll never ever intersect. However, skew lines would be this line DC and GB. You would not say that DC and GB are parallel. They'll never intersect though, because one goes over the top of the other. So they are skew lines. They're not on the same plane. Okay? So when they're not on the same plane, we call them skew. Same thing on this hex nut right here. This line and this line are never going to intersect, but you wouldn't call them parallel lines. These are skew lines because they're on different planes. Okay. Again, we'll talk about examples when you get to class tomorrow. So we're going to finish off with 2 little drawings. Get a little practice about some of the terminology that we've been discussing here in this first section. Draw a plane R which contains lines AB and lines DE, which intersect at P. C is also contained in plane R, but is not collinear with A, B, or D, E. Lots of stuff. Let's just start one sentence at a time. Draw plane R. So plane R, a plane is a flat surface, and this flat surface extends infinitely in all directions, but it's hard for us to draw infinity, so we oftentimes just draw a quadrilateral. Something like this. Alright, so oftentimes in the corners where we label that cursive script plane, where we label it, so this is plane R. Something like that. So we have the plane, and it contains A, B, and D, E, which intersect at P. So intersect means that they cross, or that they meet at a point. So it doesn't matter how you draw line AB or line DE. There could be a bunch of different right answers for this question. I'll just draw AB this way. AB lines are labeled with 2 points, so draw 2 points on that line. It doesn't have to be in that order. It could be BA, whatever, but there's my line AB. And I have another line DE, and it has to intersect, so it has to cross line AB. So I'll have it look like this. Again, you can have you could make it look a different way as long as the two lines intersect. So here is line D and point D, point E to make line DE. It intersects at point P. So I'm going to have a point right here, that intersection point, and I'll call that point P. So we got that first sentence down. Now it says C is also contained in plane R, so C lies on the plane, but it is not collinear with A, B, or DE. So if it's not collinear, we would say it's non-collinear. You just got to put C anywhere on the plane, except don't put it on line AB and don't put it on line DE. You can put C anywhere. I'll just put it right over here, because that's where I have the most room, it seems like. But you could have put it here, you could have put it there, you could have put it there, you could have put it there. It doesn't matter as long as it doesn't lie on line AB or line DE. And you have successfully drawn that picture. Last question explaining this diagram. How many planes are visible in this diagram? Now, planes are flat surfaces. So the flat surfaces, if you can kind of see this three-dimensional picture on two-dimensional paper, the front triangle is one plane, then this back triangle is two planes, and this back right triangle is three planes, and then this plane P is where this bottom triangle is on, and plane P is that exact same plane. So there's the fourth plane. So how many planes are visible in this picture? There are 4. When it says name 3 collinear points, 3 collinear points are 3 points that lie on the same line. So D and G and B are 3 points that lie on this line. So D and G and B are 3 collinear points. Now it says name 4 non-collinear points. So as long as the 4 points are not on the same line, 3 of them could be on the same line, but one of them lies on a different line. That would be 4 non-collinear points. So an example like D, G, B lie on the same line. F does not lie on that line. So those would be 3 points that are non-collinear. D, G, B, and F. You could have had other examples. You could have had E, B, C, G. Those would be 4 non-collinear points. As long as all 4 of them are not on the same line, they would be non-collinear. Do EF and AB intersect? If yes, at what point? EF is right here. Now when it hits this point E right here that lies on the plane, and then it has a dotted line, that means that it's going through the plane. So picture the plane running horizontal, and FE is running vertical, and it goes right through that plane. AB lies on the plane. Would they ever intersect? Lines extend infinitely, so you can almost kind of picture it running like this. It kind of looks like they would cross right here, but remember this dotted line means that it's underneath the plane. It's going through it. So the answer is no. These two would be skewed lines, non-coplanar lines that never intersect. So that is the answer for question number 4. I hope this made sense. Let me know if you have questions when you get to class tomorrow.